The next step is to draw the circuit diagram. As I've told you, we need 3 flip-flops to represent this counter. So this is flip-flop 2, D flip-flop 2, then I have D flip-flop 1, and I also have D flip-flop 0. The first step is give the clock signal to all these flip-flops. So you have clock, which is fed into this flip-flop, this flip-flop, and this flip-flop. Now remember, each flip-flop has D2, Q2, D1, Q1, D0, and Q0. Also, they have clear N and pre-N. Clear N, pre-N, clear N, and pre-N. All these are active low signals or active low inputs. The second input to your circuit is the reset input. Now we know that your initial sequence is, or your reset state is 0, 1, 0. So what we are going to do is we are going to make D flip-flop 2 as reset to 0, D flip-flop 1 as reset to 1, and flip-flop 0 as reset to 0. How do we do this? Now remember, if you want to set something to 0 or reset to 0, you need to take the reset signal and give it to clear N. So if you look back, it said that when reset is 0, you're in this state, 0, 1, 0. I'm doing the same thing, which is when reset is 0, that is when clear N is activated and Q2 comes out to be 0. At the same time, I need to set pre-N to logic 1. So that takes care of flip-flop 2. Now flip-flop 1 is reset to 1. So I take the reset signal and I give it to pre-N. So that makes pre-N as 0, which means it is going to set your flip-flop output as 1. And at the same time, I'm going to give logic 1 to clear N. So you're basically disabling the clear operation. Now flip-flop 0 is reset to 0. So I'm going to take my reset signal and give it to clear N. Similarly, pre-N will be set to 1. This ensures that Q2 is always 0, Q1 is always 1, and Q0 is always 0 when you hit the reset button. Okay, that completes your clock and reset. Now we need to find, or we need to give inputs to D0, D1, and D2. D0 is Q1 prime. So take this, send it through a NOT gate, and give it to D0. So D0 equals Q1 prime. Similarly, D1 equals Q2 prime. So take output from Q2, send it through a NOT gate, and give it to D1. Now D2 is Q2 prime. So take Q2 prime from here. Q1, so that's this one here, and Q0 prime, which is this one, but you have to invert it, send it here, and then you do the AND operation. So an AND gate, the output of the AND gate is fed to D2. So this is how you design the counter.